What if you could learn data science, AI, cybersecurity, cloud computing, digital marketing, and even project management completely free? No fees, no catch. And yes, you get a certificate too. Welcome to OMNI Academy, Pakistan's leading IT training institute since 2010, part of MHSG Consulting Group, helping thousands build real-world skills and land jobs. Every month, OMNI Academy offers 50+ free workshops taught by industry experts covering everything from AI and cloud to cybersecurity, networking, and more. Whether you're a student, a professional, or just starting out, there's something for you. Join online from anywhere in Pakistan, Karachi, Lahore, Islamabad, or beyond. So don't wait. Register now at omniacademy.com and secure your spot today. OMNI Academy, your career transformation starts here, and it starts free.
Welcome to today's free Oracle Database SQL Expert Course Workshop. I hope everyone is doing well. Before we begin, I want you to think about something. Every time you log into a banking application, check your transaction history, place an online order, register for a course, book a flight, or even create an account on a website, there is a very high chance that a database is working behind the scenes. You see a screen, you click a button, you enter some information, but behind that simple interface, there may be millions of records being stored, updated, searched, and processed. And SQL is one of the most important languages used to communicate with those databases. Today, we're going to explore Oracle Database and SQL from a practical perspective. This is not going to be a workshop where we simply memorize commands. The goal is to understand why SQL is used, how it works, how Oracle databases store information, and how you can write queries to work with real data. Whether you are completely new to databases, a student, a software developer, an IT professional, a data analyst, an ERP professional, or someone planning to build a career in Oracle technologies, this workshop will give you a strong starting point. What is a database? Let's start with the most basic question. What exactly is a database? A database is an organized collection of information that allows us to store, manage, retrieve, and manipulate data efficiently. Imagine a company has 100,000 customers. For every customer, the company may need to store name, email, phone number, address, customer ID, registration date, account status, purchase history. Now, imagine storing all of this information in hundreds of Excel files. It would quickly become difficult to manage. Finding a particular customer could take time. Updating information could create duplicates. Multiple employees could accidentally overwrite information. Generating reports could become complicated. This is where a database system becomes useful. A database allows organizations to store structured information in a way that can be searched, updated, controlled, and analyzed efficiently. An Oracle database is one of the most widely known relational database management systems used in enterprise environments. What is Oracle Database? Now, let's talk specifically about Oracle. Oracle Database is a relational database management system. In simple words, it is software that allows organizations to store and manage large amounts of structured data. Oracle databases are commonly used in enterprise environments where organizations need reliability, security, performance, scalability, and strong data management. Think about industries such as banking, telecommunications, healthcare, retail, government, education, manufacturing, airlines, insurance, large enterprise applications. These organizations can have huge volumes of data. Oracle provides tools and technologies to manage that information. But there is an important distinction. Oracle Database is the database system. SQL is the language we use to communicate with the database. What is SQL? SQL stands for Structured Query Language. SQL allows us to communicate with relational databases. For example, suppose we have a table called employees, and it contains employee ID, employee name, department, salary, job title. We can use SQL to ask the database questions. For example, show me all employees. Show me employees working in IT. Show me employees earning more than 100,000. How many employees are there? What is the average salary? Which department has the highest number of employees? We can also use SQL to insert new records, update existing records, and delete records. So SQL is not simply about retrieving data. It allows us to work with data. Understanding tables. Now let's understand one of the most important concepts in relational databases, tables. A table is where data is stored. If you have worked with Excel, you already have a basic idea. Imagine an employee table. The columns could be employee ID, first name, last name, department, salary, and the rows represent individual employees. For example, 101 Ali Khan IT, 122000, 102 Sarah Ahmed HR 95,000, 103 Hamza Malik Finance 14000. Here each row represents an employee. Each column represents a specific type of information. This gives us two important terms. Row. A row represents a record. Column. A column represents an attribute or field. This is one of the first concepts you should understand before writing SQL. Creating a table. Now let's imagine that we want to create our own employee table. We can use the create table statement. For example, create table employees. Employee ID number, first name varchar 250, last name varchar 250, department varchar 250, salary number. Let's break this down. Create table tells Oracle that we want to create a table. Employees is the table name. Then we define our columns. Employee ID is a number. First name is text. Last name is text. Department is text. Salary is a number. Notice that Oracle uses data types. Data types are extremely important. Understanding data types. A database needs to know what type of information will be stored in each column. For example, a person's name is text. A salary is numeric. A date is a date. Oracle provides different data types for different requirements. Some commonly used Oracle data types include number, varchar2, date, timestamp, char, cla, blob. Let's look at the most common ones. Number. Number is used for numeric values. For example, salary, quantity, age, price, employee ID. Varchar2. Varchar2 is commonly used for variable length text. For example, name, email, department address. Date. Date is used for date and time information. For example, joining date, order date, transaction date. Timestamp. Timestamp provides more detailed date and time information. Understanding data types is important because choosing the right data type affects how your database stores and handles information. Inserting data. We have created a table, but currently the table is empty. So how do we add information? We use the insert statement. For example, insert into employees, employee ID, first name, last name, department, salary, values, 101, Ali, Khan, IT, 120000. This inserts one employee. We can add another. Insert into employees, employee ID, first name, last name, department, salary, values, 102, Sarah, Ahmed, HR, 95,000. And another. Insert into employees, employee ID, first name, last name, department, salary, values, 103, Hamza, Malik, finance, 14000. Now our table contains data. But how do we see it? That's where one of the most important SQL commands comes in. Select statement. The select statement is probably the SQL command you will use most frequently. It allows us to retrieve information from the database. For example, select star from employees. The asterisk means all columns. So this query says, show me everything from the employees table. We can also select specific columns. Select first name, department from employees. Now Oracle will return only the employee's first name and department. This is an important habit. Instead of always selecting every column, select only the information you actually need. Filtering data with where. Now imagine our company has thousands of employees. We don't want to display everyone. Suppose we want only employees working in IT. We can use where. Select R from employees where department equals IT. Now Oracle returns only employees whose department is IT. We can also filter based on salary. Select R from employees where salary greater than 100,000. This means show employees whose salary is greater than 100,000. We can use different comparison operators. Equal, equal, not equal, greater than, less than, greater than or equal, AI. These operators are fundamental to SQL, and in OR. Sometimes one condition is not enough. Suppose we want employees who work in IT and earn more than 100,000. We can write select R from employees where department equals IT and salary greater than 100,000. The AND operator means both conditions must be true. Now suppose we want employees from either IT or finance. We can use OR. Select R from employees where department equals IT or department equals finance. This allows us to combine conditions. Between, suppose we want employees whose salaries are between 80,000 and 150,000. We can use between. Select R from employees where salary between 80,000 and 150,000. This makes the query easier to read than writing multiple conditions. In operator. Now imagine we want employees from several departments, for example IT, HR, finance. Instead of writing multiple OR conditions, we can use in. Select R from employees where department in IT, HR, finance. This is cleaner and easier to maintain. Like operator. Now let's say we want to find employees whose first name starts with A. We can use like. Select R from employees where first name like A%. The percent sign is a wildcard. It means any number of characters can follow. So this can match names such as Ali, Ahmed, Aisha. Another useful pattern is where first name like %A. This searches for names ending in A. And where first name like %and %. This searches for names containing an. Like becomes particularly useful when working with search functionality. Sorting data with order by. Suppose we want employees listed from the highest salary to the lowest. We can use order by. Select R from employees order by salary desk. Desk means descending. For lowest to highest, select R from employees order by salary ASC. ASC means ascending. You can also sort by multiple columns. For example, select R from employees order by department ASC, salary desk. This first sorts by department and then sorts salaries within each department. Distinct. Sometimes our table contains repeated values. Suppose many employees work in the same department. If we want to see the list of unique departments, we can use distinct. Select distinct department from employees. Instead of seeing IT, HR, finance, we get distinct department values. IT, HR, finance. This is very useful for analyzing categories. Aggregate functions. Now we move into an extremely important area of SQL, aggregate functions. Aggregate functions allow us to perform calculations on multiple rows. Common aggregate functions include count, sum, AVG, min, max. Let's look at them. Count, how many employees are there? Select count star from employees. Sum, what is the total salary? Select sum salary from employees. AVG, what is the average salary? Select AVG salary from employees. Max, what is the highest salary? Select max salary from employees. Min, what is the lowest salary? Select min salary from employees. These functions are extremely important for reporting and analytics. Group by. Now imagine the management team asks, how many employees are in each department? We can use group by. Select department, count STI from employees group by department. Oracle groups employees based on department and counts them. We can also calculate average salary by department. Select department, AVG salary from employees group by department. This is where SQL becomes particularly powerful for business reporting. You can turn raw data into meaningful information. Having. Now suppose we want to find departments where the average salary is greater than 100,000. We can use having. Select department, AVG salary from employees group by department, having AVG salary equals 100,000. There is an important distinction here. Where filters individual rows. Having filters grouped results. This distinction is commonly tested in SQL interviews and assessments. Null values. Now let's talk about null. Null does not mean zero. It does not necessarily mean an empty string. It means the value is missing or unknown. For example, suppose some employees don't have a manager assigned. Their manager ID could be null. To find those records, we use select asterisk from employees where manager ID is null. To find records where the value exists, select asterisk from employees where manager ID is not null. We don't use manager ID equals null because null requires special handling. Updating data. Now suppose an employee receives a salary increase. We can use update. Update employees set salary equals 130,000, where employee ID equals 101. Notice the where condition. This is extremely important. If you write update employees set salary equals 130,000 without a where clause, you could update every employee, so always be careful when using update. Delete. Similarly, we can delete records using delete. For example, delete from employees, where employee ID equals 103. This removes the employee with ID 103. Again, the where clause matters. A statement like delete from employees can remove all records from the table. So when working with production databases, always understand exactly what your query will affect before executing it. Primary keys. Now let's move toward database design. One of the most important concepts is the primary key. A primary key uniquely identifies each record in a table. For example, employee ID. Every employee should have a unique employee ID. We can define it as a primary key. Create table employees, employee ID number primary key, first name varchar 250, last name varchar 250, department varchar 250, salary number. A primary key cannot contain duplicate values. It also cannot contain null. This helps maintain data integrity. Foreign keys. Now imagine we have another table called departments. It contains department ID, department name. Our employee table could contain a department ID that references the department table. This creates a relationship between the two tables. That relationship can be enforced using a foreign key. For example, foreign key department ID references department's department ID. This is one of the foundations of relational database design. Understanding relationships. Tables can have relationships. Some common relationships are one-to-one, one-to-many, many-to-many. For example, one department can have many employees. That's a one-to-many relationship. One employee can have one employee record. And in a many-to-many situation, we might have students and courses. One student can enroll in multiple courses. One course can have multiple students. A bridge or junction table is often used to manage this type of relationship. Understanding relationships becomes very important as your database designs become more complex. Joins. Now we reach one of the most important SQL topics, joins. In real-world databases, information is usually distributed across multiple tables. For example, customers, orders, products, employees, departments, invoices, payments. We often need to combine information from these tables. That's what join allows us to do. Suppose we have employees and departments. The employee table contains department ID. The department table also contains department ID. We can join them. Select e.employee ID, e.firstname, d.department name. From employees E, join departments D on e.department ID equals d.department ID. This allows us to display employee information together with department information. Types of joins. There are several important types of joins. Inner join, left join, right join, full outer join. Let's understand them conceptually. Inner join returns matching records from both tables. If an employee has a matching department, the record appears. Left join returns all records from the left table and matching records from the right table. Even if there is no matching record, the left side record can still appear. Right join works in the opposite direction. Full outer join returns matching and non-matching records from both sides. Understanding joins is one of the biggest steps from beginner SQL to professional SQL. Subqueries. Sometimes we need the result of one query to be used inside another query. This is where subqueries become useful. Suppose we want to find employees earning more than the average salary. First, we could calculate the average salary, then we can use that result in another query. Select star from employees where salary greater than AVG salary from employees. The inner query calculates the average salary. The outer query finds employees whose salary is greater than that average. This is a simple but powerful example of a subquery. Case statement. SQL can also perform conditional logic. For example, suppose we want to classify employees based on salary. We could write select first name, salary, case when salary, d.add 150,000, then high. When salary equals 100,000, then medium. Else standard end as salary category from employees. Now Oracle creates a category based on salary. This can be useful in reporting. For example, high value customer, medium value customer, low value customer, or senior, mid-level, junior. SQL can be used to create meaningful business classifications directly from data. Date handling in Oracle. Oracle provides strong support for date and time operations. Suppose we have an employee joining date. We may want to find employees who joined after a particular date. Select all from employees where hire date D equals date 2025-0101. We can also use functions for date calculations. For example, we may want to determine how long an employee has been with the company. Oracle provides functions and expressions that allow us to work with dates. Date handling is particularly important in HR systems, banking, finance, sales, reporting, ERP systems, transaction processing. SQL functions. Oracle provides many built-in SQL functions. These functions help us manipulate and analyze data. Some examples include upper, lower, length, subster, round, trunk, NVL, coalesce. Let's look at a simple example. Suppose names are stored in different formats. We can use select upper first name from employees. This converts the result to uppercase. Similarly, select lower first name from employees, converts it to lowercase. We can use length. Select first name, length first name from employees. This returns the length of the name. These functions become extremely useful when cleaning and transforming data. NVL. One useful Oracle-specific function is NVL. Suppose a commission column contains null values. We want null commission to appear as 0. We can use select employee ID, NVL commission 0 from employees. If commission is null, Oracle returns 0. This is a simple example of handling missing data. Views. Now let's talk about views. A view is essentially a stored query that can be treated like a virtual table. For example, create view IT employees as select employee ID, first name, salary from employees, where department equals IT. Now we can query select all from IT employees. Views can be useful for simplifying complex queries, providing controlled access to data, creating reporting layers, improving usability for business users. Views are widely used in enterprise database environments. Transactions. Now let's discuss transactions. Imagine you are transferring money from one bank account to another. Two things need to happen. Money needs to be removed from one account. Money needs to be added to another account. What happens if the first operation succeeds but the second fails? That could create a serious problem. This is where transaction management becomes important. Common transaction commands include commit, rollback, savepoint. Commit permanently saves the transaction. Rollback reverses uncommitted changes. Savepoint allows us to create a point that we can roll back to. For example, update employees set salary equals salary plus 5,000 where department equals IT. Commit. Once committed, the change is saved. SQL versus PL/SQL. At this point, you may hear another term in the Oracle world, PL/SQL. SQL is used to interact with data. PL/SQL is Oracle's procedural extension to SQL. It allows us to use variables, loops, conditions, procedures, functions, exception handling. For example, SQL can retrieve data. PL/SQL can help us build more complex database-side logic. This distinction becomes important for people moving toward Oracle development, database programming, and advanced Oracle roles. Real-world SQL example. Let's imagine a real company. The company has thousands of customers. Every customer can place multiple orders. The company wants a report showing customer name, number of orders, total order value, average order value. We could use multiple tables and aggregate functions to build such a report. This is the kind of work SQL professionals perform regularly. SQL is not simply about writing select star. The real skill is understanding the business question and converting it into a database query. For example, the business asks, which customers generated the highest revenue this year? Your job is to understand which tables contain customers, which table contains orders, which column represents revenue, which dates should be included, how should refunds be handled, should canceled orders be excluded, how should customers with no orders be treated. Then you design the SQL query. That is where SQL expertise starts becoming valuable. SQL performance. Now let's talk about performance. Imagine your table contains 100 rows. Almost any reasonable query will be fast. Now imagine it contains 10 million rows, 100 million rows, or even more. Suddenly, query performance becomes extremely important. One of the concepts that helps improve query performance is an index. An index can help Oracle locate data more efficiently. For example, create index IDX employee department on employee's department ID. Indexes can improve query performance, but they also come with trade-offs. They consume storage. They can affect insert and update performance. Therefore, indexing should be planned carefully. This is one reason database professionals need to understand both SQL and database architecture. SQL best practices. Let's go through some practical SQL habits. First, don't blindly use select star. Select only the columns you need. Second, use meaningful aliases. For example, select E first name D department name from employees E, join departments D on E department ID equals D department ID. Third, always be careful with update and delete. Check your where condition. Fourth, format complex queries properly. Readable SQL is easier to debug. Fifth, understand your data before writing the query. Don't just start typing SQL. First, understand the tables, columns, relationships, and business requirement, especially when working with update or delete statements. Common SQL interview questions. If you're planning a career in database technologies, SQL interviews are very common. You may be asked, what is SQL? What is a primary key? What is a foreign key? What is the difference between where and having? What is the difference between delete, truncate, and drop? What is an inner join? What is a left join? What is normalization? What is an index? What is a view? What is a subquery? What is a transaction? What is the difference between SQL and PLSQL? These are concepts you should gradually become comfortable with. Practical exercise. Now let's imagine we have this table: employees, employee ID, name, department, salary, city. We have the following employees: Ali, IT, 120,000, Karachi; Sarah, HR, 95,000, Lahore; Ahmed, IT, 150,000, Islamabad; Hina, Finance, 140,000, Karachi; Usman, HR, 85,000, Karachi. Now let's practice. Question 1. Show all employees. Select star from employees. Question 2. Show only employees from IT. Select star from employees where department equals IT. Question 3. Show employees earning more than 100,000. Select star from employees where salary greater than 100,000. Question 4. Show employees from Karachi. Select star from employees where city equals Karachi. Question 5. Show the highest salary. Select max salary from employees. Question 6. Show the average salary. Select AVG salary from employees. Question 7. Count employees by department. Select department, count star from employees group by department. This is the type of practice that helps you move from simply watching SQL tutorials to actually understanding SQL. Building your SQL learning path. If you want to become strong in Oracle SQL, don't try to learn everything in one day. Build your skills step by step. Start with database fundamentals, tables, rows and columns, data types, select, where, order by, insert, update, delete. Then move toward functions, group by, having, joins, subqueries, case, date functions, string functions, null handling. Then advance into views, index, transactions, constraints, database design, performance optimization, PLSQL, stored procedures, functions, triggers, packages, and eventually Oracle administration, backup and recovery, security, performance tuning, high availability, enterprise Oracle architecture. This gives you a structured path rather than randomly learning SQL commands. Career opportunities. Now let's talk about career possibilities. Learning Oracle and SQL can support different career paths. You can explore roles such as SQL Developer, Oracle SQL Developer, Oracle Database Developer, Oracle PLSQL Developer, Database Administrator, Oracle DBA, Data Analyst, Business Intelligence Developer, ERP Technical Consultant, Database Support Engineer, Application Developer, Data Engineer, and other database-related positions. Of course, SQL alone does not guarantee a job. You need practical skills. You need to understand databases, you need projects, you need problem-solving ability, and depending on your target role, you may also need Oracle administration, PLSQL, cloud technologies, ERP knowledge, or data analytics skills. Why practical learning matters. One of the biggest mistakes beginners make is spending months watching tutorials without actually writing queries. You can watch someone write 500 SQL queries, but that doesn't mean you can write them yourself. The best approach is learn a concept, write the query, change the query, break the query, fix the query, try a different data set, solve a problem without looking at the answer. That's how you build confidence. For example, don't just memorize select star from employees. Ask yourself, recap. Let's quickly review what we covered today. We started with what is a database? What is Oracle database? What is SQL? Then we discussed tables, rows, columns, data types, create table, insert, select, where and or between, in, like, order by, distinct, aggregate functions, group by, having, null, update, delete, primary keys, foreign keys, relationships, joins, subqueries, case, date handling, SQL functions, NVL views, transactions, PL SQL indexes, SQL performance, best practices, interview questions, and career paths. That's a lot to cover in one workshop. But remember, today's session is the starting point. Becoming an SQL expert comes from consistent practice. Closing. So if today's workshop gave you a better understanding of Oracle database and SQL, don't stop here. Take what you learned today and start practicing. Create a small database. Create your own tables. Insert some data. Write select queries. Experiment with where conditions. Practice joins. Try group by. Write subqueries, and gradually move toward more advanced Oracle technologies. For those who want to take their learning further, OMNI Academy also offers structured training programs covering Oracle, SQL, ERP, databases, IT, cybersecurity, cloud, programming, and other professional skills. If you're interested in continuing your Oracle learning journey, you can explore the available Oracle training programs and choose the path that matches your career goals. Also, if you join this workshop through OMNI Academy, keep an eye on our upcoming free workshops and professional training sessions. And don't forget, workshop participants can also check the available 20% discount on eligible training registrations, valid for 7 days after the workshop, where applicable. You can also visit the OMNI Jobs and Internships portal to explore current career opportunities and internships. And if you're looking for job opportunities in Pakistan, Saudi Arabia, remote roles, internships, and other career openings, make sure you subscribe to our OMNI Jobs WhatsApp channel so you can receive new opportunities directly. Thank you so much for joining today's free Oracle Database SQL Expert Course Workshop. I hope you enjoyed the session, learned something useful, and most importantly, got a clear idea of where SQL and Oracle can take you. Keep practicing, keep learning, and we'll see you in the next workshop.